Assalamualaikum and very good day to the parents. Today I'm going to present my FIP project with the title of Modeling and Simulation of Trajectory Planning for Rotary Robot. My name is MOHAMAD ZA'IM IRFAN bin Abdul and my ID number is 2017389247. Today I'm going to present 5 topics in this slide, which is project summary, introduction, methodology, expected result, and appendix. All the topic is vital to this FIP project. Before I start my presentation, I would like to thank my supervisor, which is Prof. Dr. IR Muhammad Azmi, and the co-supervisors, Dr. Nulaila Shah and Dr. Muhammad Azmi Abdul. Topic 1. Project summary. In this topic, I will briefly explain about the FIP project, what we want to study, and what software that will be used in this project. Project summary. In this project, the movement of the body object from one place to another will cause the vibration of the mass while moving. The reason for the phenomenon is due to 2 reasons, which is due to the motion of the mass itself will initiate another mass. Secondly, because of the motion of the pendulum will affect the specific motion of its support. In order to get the trajectory planning, we have to counter these 2 reasons, and that's what the project is about. The aim to get the reduction in the sway while moving from one place to another. In this project, I'll use MATLAB and Simulink for modeling and simulation. Topic 2. This topic have 3 content, which is review literature, problem statement, objective, and scope and limitation. Review. First is Furuta pendulum. In this project, we have used Furuta pendulum to further the study. The Furuta pendulum system is the system used as reference in the project for the application on result. The structure of the Furuta pendulum have been taken out to use as reference for this project. Furuta pendulum also been known as rotational pendulum, which is a system that contains 1 control input and 2 mechanical degree of freedom. In the Furuta pendulum, there are 2 control problems to be concerned about, which is balancing up the vertical pendulum to the upper unstable position, and second, the stabilization in the position. These 2 problems relate to the project to eliminate the sway while moving with speed in prescripted manner. A cam follower system is the second literature review. A cam follower system is engine if the system that start at rest and come to rest in the second position, which means the mass move without inducing any vibration in the mass being moved. The project is motivated by the system to ensure the stability while moving of the mass. Problem statement. Crane system is the most identical application to the study. The sway that causes the unwanted sway and increase the acceleration required for motion at a high speed. Consequences to this situation take time to unload until it stops swaying, torque efficiency, load damages, and even accidents. The 2 problems are considered here: the motion of a mass initiated by another mass, and the motion of pendulum initiated by specified motion if it supports. Objective. We have 3 objectives for this project. First, to study the trajectory planning in the motion control system of rotary robot. Second, to formulate the program of trajectory planning motion control system of rotary robot. Third, to simulate and evaluate the performance of the program design in simulation. Scope and limitation. We have 3 scope and limitation, which the formula of trajectory planning is taken from the journal. Second, use MATLAB and Simulink to simulate and modeling the formulas. Third, do not apply to the hardware or any physical component. Use simulation only. 3. Methodology is a step in the project for analysis and simulation. In the project, there were 5 big events happened during the process of simulation and modeling. First one is to understand the formula in the journal. Second, to create graph based on the formula. Third, graph obtained being used in 4. Simulate and evaluate the performance. 5. Technical analysis. All you can see the diagram in the slide. There is a step for simulation and modeling. Understand the formula. Start by read the journal with the title of a strategy moving a mass from one point to another. In this journal, the shape of engine can follow a system has been used in the formula. The first one, moving a mass from one point to another. This formula is about to desire to move a mass from one point to another without initiate a vibration in the mass being moved. In the formula, 1 minus cos has been used because of the shape of the engine can follow a system. The value for alpha is 3 because in order to minimize the time. Second, a strategy for moving a pendulum from one position to another position without overshoot. In this formula, we seek a strategy for moving the support in the precipitated fashion so that when the support has moved the distance d, the pendulum again comes to rest. Work on simple pendulum only, which is not a compound pendulum. Alpha 3 has been used because give the minimum time to move the system distance d as well as the smoothest motion. Generate the graph. Use MATLAB to generate the graph. In this first picture, the left side is the specified displacement coding for the MATLAB, the coding that I used to generate the graph. The right side result of the coding show the graph obtained from the coding. Comparison of the graph. Both of the graph in the same manner, which is the graph from the journal is same with the graph that I obtained from the MATLAB. So we can say that the coding is correct. Generate graph for the second formula. We use the same step. Start by creating the coding for the formulas. After that, we run the program to get the result of the graph. Then, as you can see on the left in the right side of the slide, you can see the picture, the graph result from the coding. In this slide, we can see the same graph obtained from the journal and the simulation. The comparison in this slide show that it means the graph is successful generate and show the same result as the journal. The same results say that the coding is correct and it's successful simulation. Then from the x naught t, we have to convert it into the delta t. The formula changed due to rotational movement of the robot. According to the formula, delta equal to s over r. The value of the delta can obtain from the formula. So we have to assume the value for r. I have assumed the value of r is equal to 20 centimeter. In this picture, you can see the coding for the graph. The graph obtained for rotational movement same as the linear, but increase in the value of distance. After obtain the graph, further simulation has been made through Simulink. After generate the trajectory graph through MATLAB, the trajectory graph has been transferred to the Simulink application. Simulink is the sub-application in the MATLAB that functional to simulate modeling, simulating and analysis multi-domain dynamical system. The simulation of the trajectory planning in the Simulink start by choosing the right block or suitable block for trajectory planning. In the case for this project, the block of MATLAB function has been chosen as the main block for trajectory planning simulation and analysis. It is because the block can put the configuration coding obtained from the MATLAB. Then we have to choose the line to link the block with another block before get a result. So the result will obtain if you double click the scope. Scope is another block in the MATLAB simulation. In the picture, this is the result of simulation. The blue line is the rotational movement, Yellow line is the linear movement and the orange is a pendulum motion graph. The result of the graph is obtained from the simulate. Use the same coding as MATLAB, then we transfer to Simulink and get the same graph, but in the Simulink. Simulate and evaluate the performance. After finish with trajectory planning, the process of simulating and modeling continues by midst the DC motor simulation and analysis. It was the final process of analysis for FYP1. The result obtained will be used in the FYP2. The result of simulation and modeling generate as the graph input and output from the block system. Technical analysis. In this project, technical analysis has been founded was the effect moment of inertia at link 1 and link 2. Due to rotational force, the Coriolis effect can be assumed to happen at the place. Coriolis force is inertia that act on the object that are in motion within the frame of reference that rotate concerning an initial frame. The deflection of an object due to the Coriolis force is the Coriolis effect. Expected result. To understanding of the theoretical analysis and technical analysis of the project before proceed to simulation and analysis, data collect for strength the study in the literature review can be mentioned as outcome for this project. The outcome of the analysis from the software will be used to create roadmap for improving the resources in the next semester for FYP2. The modeling and simulation of the trajectory planning in this project has been created using the formula in the journal. The result of simulation could be changing due to parameter or the new trajectory planning formula used in the further research. Gantt chart. This is the activities throughout the semester for FYP1. It took almost 14 weeks to finish the proposal and the meeting with the supervisor. That's all from me. Thank you.